All right, let's start our class. Hello, everyone. Welcome back to this week. And as you already see, if you already watched the video, you know that this week we are looking at Stack Overflow vulnerabilities. So I hope that you already watched the videos, and also many of you are asking questions like why my machine doesn't work if I'm using the code that are shown in the demo from the video. So those are good questions to ask. I saw that some of you have this like Python 2, Python 3 problem, like you're using Python 2, but then the encoding is different. Because the one that I'm showing is using Python 3, whereas you're using Python 2, right? And then also some of you have questions about like how to compile the program so that those vulnerabilities is exposed to you for it to attack, right? So you need to, like right now, for the demos that I'm showing, you need to turn off ASLR. You need to let me think about, you need to enable NX, means that you need to enable the stack execution and also no stack canary, like no stack protection. So those are the necessary compiler options. The ASLR is not. The ASLR is a system configuration, but besides that, the others, there are compiler options. So if you are trying to replicate what I show from the video, you need to compile them with the right option. Other than that, is there any questions, regarding the video or anything? Yes.
So I used the same trick when I had having a shell code, having it with a couple of characters that they have the address of the starting of that buffer.
Yeah.
So the thing is that A, the shell code does not execute. B, I'm checking the RIP address.
Mm-hmm.
It's still showing some padding characters and not the exact address of it.
Uh-huh.
So I believe that the way that I'm making that string using shell code plus whatever the padding plus using struct, it is not giving me the right.
Yeah.
string.
Yeah.
So I'm not able to figure it out.
Sure.
Like it's giving me E on every time.
Okay, yeah. So the question here, which is pretty general, like I tried, it didn't work, right? Like I tried to put the shellcode there and I tried to run it, but I found that when the return RIP was overwritten, it is not overwritten as expected, right? There's paddings there, right? And then like in general, like the question is, how can I debug it or how can I fix it in the cases like this, right? So my suggestion, like a general suggestion, is that first of all, it's good that you already figured out the reason why. It's not like I don't know why, but it doesn't work. So is because of the RIP is not overwritten the right value, right? And then the next that you could do is that you figured out where are those padding from. Is that the padding is because of like, what is the padding's character? Is it things like \n,
yeah,
right?
It's small that you put typically.
Is it what?
It's the small a character that you
Okay, yeah, it's the small a character that.
that's extending to a point.
Uh-huh. Yeah, yeah.
Like the math, the 72 minus the efficient code, math is wrong. But it does not make sense to revise it.
Yeah. So in that case, that as you said, like the math must be wrong because the A characters shouldn't be in part of the returned RIP, right? So, and then also in that case, because that hints that you put too many A's there, because A should be before the return value of the RIP, right? So if I were you, I would just try to cut some A's there. And it looks to you that if you find extra paddings, depending on how the length of the paddings, if you have like 2 A's, then you want to remove 2 A's. If you have 1 A, then you want to remove 1 A, and then try it again and see if that works. Yeah, so try if that works. And if not, then you can also, come to my office hour and I can help you debug. All right, cool. Okay. If there's no more other questions, then as I show here, we are going to exploit the service in port 3333 again this week. The binary is different from last time though. So you can get the service file and also the service binary over there. Yeah, and then you can start. Actually, the service binary may not be different, may not be the same as what I'm having in the website right now. I'm going to update the binary, but the service source code should be the same. But let me just double check real quick. It's actually the same, so you're good. Yeah.
If we are in a poster, like debugging and we use info frame, to really develop.
Yeah, you can use user.
RIP at the end, it's the return, address of the policy, right?
The return address of the caller function, not the callee function, right? And then save the RIP. Yeah, so there are two things. One is RIP, which is the current function, and the other is the save the RIP, and that should be, and that is it's the next instruction of the caller function. So that means that after you call function like vol, right? And then you will return back to the original function. Yes, and that's the next instruction right after the call.
Save that,
Right,
which is at the RIP.
right, exactly. You need to look at the saved RIP.
If the active method, we encounter the first buffer
Mm-hmm.
when we are connecting the values.
Yeah.
If we can redirect it, if we can give a invalid, number. it goes
Yeah, the
to
invalid what?
Invalid option.
Yes, invalid option.
Like log files, we should get an invalid number. It might go back to the return statement of the invalid that we get, go to like the bit.
Yeah, if you give it, like if you override the returned RIP, then you can let the RIP to go to like the wing function, which is what you're targeting for. So basically you need to figure out a way to overwrite that returned RIP play. Yeah. Hey.
So I have it working on my local machine.
Mhm.
I'm just like,
Does it work on the remote?
yeah,
Okay.
I'm brute forcing the last like bytes, just
Yeah.
using the known,
Yeah.
and so like,
So you're not using the return address, right? You just like brute force the last two bytes.
yeah, the last two.
Yeah.
So, I mean, I could pull it from the thing, but like I said, it works on like a local version, but
Mhm.
not the remote. So I don't know if the remote's compiled different, so it has a different like address, or if I'm just like not doing it right. Cause like, oh my God, it's,
That's good to know. Okay.
yeah, so like it,
Hmm,
cause like, I can just show you here.
let- Why?
Yeah, so
Yeah.
it's the preset, and then so
Yeah.
if I do it like this for,
So this is the, okay, let me double check the window function. It should be in
Okay,
this place, right? One for, yeah, you are right.
yeah, see, and so if I do it local, I get into like it works because I drop out, so that's the information ID.
Mhm.
But if I change it to remote, it's not working this way. So I don't know. I could just try to get the actual address and do it that way. But I don't know why it wouldn't work on the remote.
Yeah, that's weird.
I mean, it
Wonderful.
could be Pwn tools, maybe sending something weird on the remote instead of a local program, but I don't know.
It shouldn't be the case. Let me double check.
But there's no, like in Pwn in college, I sometimes have
Yeah.
issues with remote.
Mm.
I don't know if that's the problem.
It shouldn't be because I'm not using Punkcom. I mean, maybe
Yeah.
they have the same issue, but like,
Yeah, it's, I remember Pwn tools itself would sometimes give me problems with remote when I was doing the problem
I
stuff.
see. Is that MD5 some? Okay. Could you do MD? Oh,
Sure.
Yeah, all right. It is same. It's the same. Interesting. Could you? Okay, so I guess first of all, can you maybe just send me this file?
Sure.
I can debug on my end because
Yeah.
I'm just curious about this.
Okay.
And also you can use the return address for now in a
Yeah. I'll do
Yeah.
that.
Yeah.
Do
Thank
you want me to email it to you?
No, just Discord.
Okay. no worries.
Thanks. Hey,
This is the first buffer that we are getting.
Mhm.
But then there's like this, if we try to, even if we at this point, if we try to like override the buffer, like
Mhm.
override the stack, but then
Mhm.
there's A2I, which will generate some error and then the code execution will stop. So is it like not the correct buffer to target?
you're right. That's not the correct buffer that you want to target.
Okay, so there's another involvement.
Yes, there's another vulnerability. Yeah.
So your GDP looks different.
Huh?
Your GDP looks way different than ours.
You mean the one from the video,
Yeah,
right?
so you have a stack.
Yeah, you will get this kind of like better form of GDB later. Like when we talk about heap, you will have to use it. It's just a plugin. It's very easy to install. But just like right now, I don't tell anyone about that because you don't have to be that fancy to work on what you need to work on right now.
Easier to like access the stack. We have to like
Oh, is it? I never
slash, yeah, and like-
I actually never.
Your videos
Yeah.
are very easy to see all the information.
And like the stack doesn't work. Like,
No, GDB also has BT.
Yeah, so like you like stack.
Uh-huh.
And like the stack
But
command.
also all the information is always free with.
Yeah.
I never use that command actually.
In the video.
It shows like it's like whenever you hit, it will show that automatically. But I never like kind of I don't really read that information because I know it's not really important. It's I mean it's definitely helpful. You can read it, but like you can use the same command, one line command in GDB to achieve the same effect. Hey, so,
For the video challenge, or
Mhm.
video which you showed,
Mhm.
the attack, for me, it always goes to ear for some reason.
Okay, show me. It goes to,
I'm not sure. what it's doing like that. So this was the same code and this is the one I could see. I'm getting the address and all like if I see the address buffer size, it's always I have disabled ASLR
Mhm.
and the address I'm getting is this one. But whenever I try to
Mhm.
attack,
Yeah.
suppose I do what you
Okay, do you know where you are? Like, is this actually being executed or not? Can you debug it?
so I go to GPP.
Mm-hmm.
And I'll just run it again.
Mm-hmm.
Mm, check.
Oh, you need to enable the execution of the stack. So
Okay.
you need to do, I think I should mention that. I don't know, did I mention that in the slides or not?
No, this slide and video was not mentioned, and that's what I was.
Okay, so what you need to do is to use this command. GCC dash Z X EXCC stack means that you want to enable the execution of the stack and also no stack protector. You compile them,
Minus G, what?
right?
is it?
Minus Z,
Minus Z.
right? And then EXEC stack. Right. And then the minus F, no, it's no space.
Okay.
F, no, right? No dash stack dash protector. Right. And that's it. Oh, you need to,
Sorry. I'll just GDB, maybe with that same service.
mhm.
I just see my info. I'll just see my stack. What is the problem? Should I attach with my Python and with the PID and then check?
No, you can run it now. Like if you just do, right, and then now it's running.
Mm,
So if you want to debug it with the input that with the input that you already get there,
Yeah.
you,
Put a breakpoint.
yes, you need to put a breakpoint. So you need to follow this, like using the way that we're showing the video to attach them.
Okay. Yeah,
Yeah.
that attaching PID.
Yeah,
of-
exactly. Yeah,
Okay.
we're also going to have another way to debug it, which I will show later in today's lab. Yeah.
Thank you.
Yeah, sure. Hey, so,
So saying I'm able to get like
yeah.
the win function, but
Mhm.
when I do like my name,
Mhm.
like, and then I check it.
Your ASU right ID is invalid.
Yeah, I'm
Oh, yeah,
not
yeah.
sure what's like, and then like it doesn't.
Yeah,
says
because it says that your ID was invalid. I guess this is because you have some special credit. Yeah, because that.
Oh, right. Sorry, I was messing up. Even when I don't do that stuff.
Okay,
I just
let's
messed.
do that again.
Yeah. just messed up. And then so I don't get it, but then if I check it, doesn't exist.
Okay, so let me try this again on my end. So could you scroll up real quick? Message.
So AM, well, yes, again. I can just
Let me try
call the
that.
shell, I guess, but I just want to make sure.
Um, let me think about this. Okay. Hold on. What I'm trying to do is that I want to double check if the service is pwnable, because looks like everything that you've done is correct.
I mean, I could try the shell code because it says it's like the stacks, it's executable, so I could just try that and get the
No,
shell.
no, I think it shouldn't be the problem like that
Yeah.
right now, because you already get goes to the win function and everything is correct. I think now the problem is that for some reason, you, I guess there is a permission issue. It looks like there is a permission issue. That's why you cannot log in. Um, you can. You can touch though. Yeah. There's not a permission issue, but
Want me to try to get a shell and just see if that works at all?
no, I don't think it will solve the problem. Let me see, because I think this is not your problem. It's probably is my problem.
Mhm.
So let me see if my scripts do work. It is there. Okay, let's do this thing.
Because one thing I notice is I'm
Mhm.
just. I'm getting into file as soon as I enter, so I don't know if like it's closing the connection because I'm not getting the like the stuff after the you got it and stuff.
Mhm.
I just get into file, so I don't know if it's closing the connection for some
And
reason.
let me try your,
Yeah.
right, I think it somehow it closes in your case. My hunch is that you may have some close.
AMOLESEN.
Definitely you can do it.
Hmm.
Okay,
Yeah,
you know what?
sounds weird.
Let me just see record real quick.
Maybe it's my clean, so I'm cleaning before I send it.
Have you tried that locally?
Yeah, it works locally.
Okay. Okay, could you try to have that? This is Control X. And is that Control S?
Yeah, so that's.
Okay. Could you try that again? Let's see if it works. There might be some buffer problem.
Yeah.
Do the same problem.
Yeah.
Interactive. Let me try that from the outside again. Because right now I am connecting to the Docker from the server internally.
Let me check how I did it last week and make sure. We did the same way last week.
Okay, yeah, my script still works, so means that there might be something wrong with
Yeah,
your script.
I'll mess with
But-
it a bit.
but-
Sure.
But this is interesting because you have done two options. And it seems that
Yeah,
both are getting stuck with some interesting issue.
I'll-
Um,
I can try a different install. I've got Windows on this machine. I could try to just put it on Windows and see if it's maybe my like Linux for some reason is like putting some weird in the like input. That's the only thing I could think because I don't know what it could be other than that.
Or,
Because it's the same script. like,
yeah,
last
I see
week.
your point.
Yeah.
Or let's try this, because send me the script again.
Okay.
And then I'm gonna run your script on my end and then see if it works, because
Right.
mine has this Linux or Unix system.
All right.
Good, I can replicate your problem at least.
Strange.
So it's not a system problem. Okay. I like to rebut this for you. Okay, this is interesting.
Yeah.
That's not there. Yeah, just give me a second. Good.
And I did try to just send my name as like raw bytes without being interactive. I
Mhm.
had the same issue where I couldn't see it afterwards.
Mm-hmm.
So I don't know. So I think that's not it. It's not the interactive.
Yeah. You do send everything in bytes, so that shouldn't be the problem.
Yeah.
And also, like, you already see interactive, and then you already see it asks you for you haven't interactive before. Oh,
Yeah. So it is segfaulting now.
okay, so you locally it's segfaulting.
Yeah. Last time I swear it didn't, but maybe it did.
Mhm.
I just wasn't paying attention. Let me go to my GDB and see if it's segfaulting.
Okay, then in this case, maybe you can
Yeah.
debug locally and see
Yeah. I'll do
what's
that.
going on. Right.
I'll let you know if I find it.
Okay, yeah. All right, guys. So it seems that many of you are having difficulties in exploiting this. So let's go through this challenge. And let's look at the source code first. But also, of course, if you would like to keep trying this by yourself, feel free. So you don't have to listen to, but if you do like to know how this managed to work, and I am happy to, guide you on how to exploit this. All right, so then let me reconfigure my laptop real quick so that I can also see my screen from my end. Okay. Okay, so you should be able to see my screen. It's the same. And also people from Zoom, I wonder if you can also see my virtual machine right now.
No.
Let me know if you can't. Screen is black. Okay, let me reconfigure that 1 second. There we go. Okay, so let's first read the code. This is the code that you have already, right? So can anyone tell me that where is the vulnerability? In the val function? Yes. And which line has the vulnerability in val function? Read, exactly. Cool. So you know that there is a vulnerability and we need to trigger that, right? Cool. So now you know that what you need to do is that you want to use case log so that you can go to the val function, right? And then you overflow the buffer because this buffer has a length of hex 6110, but in fact it reads hex 7 exactly 710 710. So you need to exploit that. Okay, so far so good. Okay, and something that you can potentially try is that if you already have that service, right? And then if you do log, and then you just put like a very long. Actually, you know what? I'm gonna stop doing that because I don't think I can finish typing that long bytes, but like it should work. Okay. And now the next thing is, okay, now let's start to create a script that will interact with a service. Okay. So I'm gonna do a different way from what we, tried last time, which I really like. So you use Pong. Okay, so it's once you install Pong tools package, you will have this Pong binary. And then the really nice thing about Pong is that if you do Pong template, okay, followed by the service name, like the service that you are about to exploit, and it will generate a template for you to start to work on. Okay. All right, so that again, Pong template followed by the binary. You can just put a template.py. Okay. All right. And now if you open template.py, it's very nicely that has those things. Okay. Cool. Okay. So I'm gonna just prettify this a little bit because my Vim doesn't like functions that are not defined. So I am going to calm it down. That way. Okay. Now you will not be able to see Oh, give me a second, my laptop. Does any of you have a cable that I can use? I'm sorry, I forgot to bring it. I need a charger, a Mac charger, please. Thank you, I forgot it. Cool, I'm back. All right, now let's continue. Now you have a nice template, right? And then the next thing that you want to do is to first interact with the service, as we just said. So what I normally do is that I'm gonna just write my interaction along with their service when I run it, okay? So now I know that when I run it, the first thing it's asking me about is this string, select from menu, and then comma with a space, right? Okay, so I am going to, so between my IL start and the interactive, I'm gonna do IL.receive and two. Let's see, two. This guy's called from menu, right? And then after that, I want to send a line one, right? Okay. Send line. Because I'm using Python 3, I'm going to just make everything that I receive and send in bytes. Okay. Now I'm sending a one line. And now the next step we see that it's going to give you the current return address, right? The 1 second, let me. Okay. The current return address, and then the base pointer, which is RBP in this case, right? As well as the address of the buffer. Okay. So now you have those in your mind. And also this will give you, you know, like, I'm gonna go strong. Like in your mind, you're gonna have a stack. So suppose that we already have a stack in your mind, right? And then this is my address. And this is low address. Well, actually, it's the other way. This is the low address. I'm gonna make it the same as what we showed in our slide. So here has the so-called RSP, which means that it points to the bottom of the address. By the way, can everyone see my whiteboard right now? Am I blocking? No? Okay, cool. All right, and then what it says is that it's gonna give you the return address, right? So right now we are in function val, right? And then inside the function val, let's say this is the current place that stores function vals, like related, you know, local variables, etc. And then there is a RV, right? It points somewhere. Like this is pointing the top and the bottom of function val stack. And then the return address is always at the place of RBP plus 8, right? So if you look at that, if you for better illustration, let's say that we run service, right? And then we just break in the val place, or we just can let it run, right? Is that like right now the upper screen, the lower screen, the bottom screen, they're showing like at the same stage of the service. And then now if you do Control-C, you stop there, and then you have info frame, you will see the current values of those like stack frame. So you will see that it says the RIP, let me actually, so BT, now we're in the read, but we want to go to function vault. So you could do up. Yes. Oh, okay. Sorry for that. Okay. Now it should be good. Info frame. So it says that this is the current RIP in function vol, right? Which is about to read, right? And then the saved RIP is this value. And also the saved RIP is at this particular address. And then you see that the current RBP is this place, right? So RBP plus 8 is the place that saves the returned value, which in this case is what is shown here. This is the current return address. So what we want to do is that we want to overwrite this value to, overwrite that to function win so that we can call function win by the time that vol returns. Does it make sense? I saw many of you nodding your head, but if you still don't understand, this is the perfect time to ask me and I will repeat this again. Do you want me to repeat? Yes? Okay, cool. Let me do that again. I'm gonna draw this line again, or maybe just use blue pen, okay? So this is the current stack of a function vol, okay? And then this goes to the bottom, RSB, okay? And then this goes to the top, which is RBP. And then if you look at here, it says that the current RBP's value is this place, is this value, right? So for short, I'm gonna just call it DC60, all right? So RBP's value is DC60. And that means that this is the address of this current stack location, all right? And then what it says is that the RIP saved the register, right? So the saved RIP is at this location, which is DC68. So DC68. This is the place that it stores saved RIP. Does it make sense? Okay. So, and what is the value that is currently stored? So if you look at info frame, it says that the saved RIP's value is this guy, right? So that is 555, a lot of 5 and a 5780. Okay. And in fact, if you look at this process, it also tells you this is the current return address, right? Which is the same as this. So basically what it says is that when this line was printed, it is under function vulnerability, right? So this is under function vol. And if a function vol, the return address will be 757E0. Does it make sense? So that means that by the time that function vol returns or they finish, you will need to go back to the function, the caller function, which is the function that calls function vol, right? And then in this case, that function is, can someone tell me? Because I don't remember. Is it interact? Say it again. W win. Oh no, I mean, that is the function you need to over interaction, right? Okay, cool, right. So 57E0, it's somewhere in interaction. So it's actually is interaction that calls vol, right? And then by the time that it calls vol, this act will be established for vol, and also this is the same RIP, the function, like, because when this function is finished, it has to go back, right? And then your stack will store the location of interaction after vol returns back, right? And then in fact, let's look at this real quick. Let's use GDB, Optdom. Okay, real quick. if we use opsum dash D and then service, okay? Oh, actually, yeah. Right. So this is function interaction, right? And then this is the place that it calls vol, okay? And then the next is the so-called, it is the return address, right? And then you see that now it's like, it looks very similar. This one, it says it's 17E0, but now we have like 57E0, which shares those 3 letters. You may wonder why this is different, which we will talk about when we talk about ASLR, those like defense mechanism. But now, when it says this is 57E0, it is correspond with the return address. Okay. So far, so good? Good. Okay, cool. All right. And then that's why for us, when we going back to this case, right? So when we overflow the buffer, which we know where the buffer is, right? It tells you. So it tells you that the buffer stores at this location, right? Which is D650, right? So it's D6, this is 80, so it's smaller than somewhere, right? So D650. Right, so that is the place that we put buffer. And what you want to do is that you give a long string that will overflow all the way to say the RIP, right? And then you want to put that to function wing. Does it make sense? Good. Okay. So then in this case, there are 2 things that you need to figure out. First, what's wing's address, right? Because we need to overwrite this with function wing, we have to figure it out where is wing, what is the value of wing's address, okay? And then the second is how can we get here, right? Like how many bytes that we need to write so that we can overwrite this place. Does it make sense? Okay. I'm gonna just call it offset. Okay. So offset is easy to calculate. Since now we already have this stack in our mind, we start from here. And we want to overwrite here, right? So all you need to do is do a calculation. Have this minus that. Easy? Yes? Good? And then remember that RVP's value is already given. Like, so you need to parse those string. You have this RBP's value, right? So you have that minus your buffer's address and then plus 8, right? Okay. I'm gonna write it here. This is BP minus buffer plus 8. Make sense? Offset? Okay, cool. And then the other part is wing's address. Okay. So if you look at your current binary, you will notice that the wing's address is somewhere is weird. So if you look at wing, it only has this last 2 bytes, which is 1 for FE, right? And then in fact, if you look at the code, it says that it has pi on PIE. So that means that the upper part of the function address is gonna change and it's dynamic by the time that you run it. However, the offset of each function will not be changed. So that means that if we calculate the difference between the function of wing, which in this case is 1 for F, right? So this is wing. And also we have the return, right? If you remember what we just talked about, is 17E0, right? Let me just show that real quick. right? So this is the place that returns function val, right? That is 17E0. The offset, the difference between these two won't change. And now you know the actual return address when you run the process. It already give you, right? It tells you that the current return address is this guy. So what you want to do is that you use the current return address minus this. This is hash. And then add 1 for FE, then you will get the current wing address. All right, so now putting all things together, we know this is the wing's address, and we know this is the offset, right? And all you need to do is to generate a string with this length, and then at this particular case, we're gonna put the wing's address. In that case, you should be able to call wing by yourself, and then you should be able to log yourself. Okay, good. All right. We are running out of time right now, so I cannot really show you how to write the script. But before you go, I want to show you real quick about how to debug. So if you still have problems saying that you just messed up some of the offset, right? And last time and also in the video, I show you one way to debug. Like you initiate the process, you run service, right? And then you use GDB to attach to that process. Getting the process ID, use PID off, and then you attach GDB to that. So there's another way that you could try. Which is that you can so if you generate your script using your template, then potentially what you do is you could run the template with argument, it's called GDB. So once you hit that, it will do like the attaching things automatic for you. However, you need to install GDB server. And that's why at the start of this class, if you look at the slides, it tells you that you need to install GDB server. Because in this case, you will be able to attach to the program that they're currently running. So now you see that it is at main of your program. And if you do list, you can see the program, right? And then now if you just set a breakpoint at val and then continue to execute, you'll be at this place. So it's similar, like all the others, they're the same. It's just like using this way, you can nicely call the service locally and then debug it without doing a lot of like finding PID attached, things like that. It's already automatically wrap everything for you. Okay, good. All right, good luck, guys. If you have more questions, come to my office hour, please. Okay, because it's gonna be very hard for me to debug using Discord, but I am more than happy to help you debug during office hour. All right, thanks, guys.
I try
Yes.
to use like Python to fight this thing, like virus try to figure it.
Yes.
So it gives me this weirdest number.
Mhm.
How can I convert it to this? Like, how